In this lesson, we are going to see how we are going to solve a linear and quadratic systems, and also how to determine the number of solutions. Before we start the linear quadratic system solving, we want to see how we solve a linear system, two straight lines. So y equals x minus 2, another equation is 3x minus 2x equals 7. And for such question, we want one equation with only one variable. So we have two variables in one equation, xy. We are not able to solve it unless we are looking for the vertex for quadratic function. Then without solving only one equation, we can solve for the find the p and q. But for this one, linear equation, you have xy in one equation, we are not able to solve it. The reason is xy in one equation for linear is a straight line. You will have infinite numbers of points on this line. And for solving this linear system means we have two lines, and we are looking for the point of intersections. So we want one equation with only one variable, so we want to get rid of one variable. So we have two, y is isolated. We want to replace the y in another equation by its equivalent. So we are going to sub y equals x minus 2 into equation 2. Then you will have only one variable x left. Then this is a linear equation, we are able to solve it. So we copy 3x minus 2, we only change the y to its equivalent in terms of x minus 2. Then in this equation we have x variables only. So in order to solve this linear equation, we want to get rid of the brackets because we want to collect the like terms. So minus 2x minus 2 times minus 2 give you positive 4. Then equals 7. 3x minus 2x give you 1x. And 4 is like terms with 7, so move the plus 4 to other side. By doing opposite operation, we have x equals 3. And don't forget, we are looking for the point of intersection, so x coordinate is 3. We need to solve for y. We are going to sub x equals 3 into one of the equation. Equation 1 or equation 2. Equation 1, y is isolated, so it will be easier for you to sub into equation 1 to solve for y. So y equals x, replace it with 3, then minus 2, so y equals 1. Then the final answer is, therefore, the point of intersection is x coordinate is 3, y coordinate is 1. So it's done. This is what we did for two straight lines. And today's lesson, what we are going to do is, we have a U-shape parabola, and also we have a straight line. And we want to find the point of intersection of these two graphs. So what does the solution mean on the graph of the linear system? It means the point of intersection. And we are going to use the same ideas. We want to get rid of one variable, then we have only another variable left in an equation, then we know how to solve one variable in one equation. So the steps is isolate one variable in any of the equation if needed, means isolate either x or y. Then we sub it into another equation to get rid of that isolated variable. Then solve the quadratic equation. Make sure that one side must be 0. then you could use either linear system, either factoring or quadratic formula to solve for the x. So you may have x plus, x minus, and don't forget you need to sub this one back to the isolated variable equation to solve for the variable left. So now we are going to see how. So this one you will see the y isolated already, so we just need to replace the y in one equation with the equivalent. So sub y equals x minus 2 into equation 2. It is isolated already, so we don't have to isolate it again. Then we are going to have x minus 2 equals 3x squared minus 2x minus 8. This is a quadratic equation, and we need to make sure one side is 0. So we move the x minus 2 to other side by doing opposite operation. Then you will have 0 left. 3x squared, we copy minus 2x minus 8. Then 1x move to other side, opposite is minus x. Minus 2 to other side, opposite operation is plus 2. Then collect the like terms. Same variable, same degree, so x to the exponent 1, they are the like terms. 3x squared, no other like terms, minus 2x minus 1x, minus 2 minus 1 give you minus 3x. Then minus 8 plus 2 like terms, minus 6. This is a trinomials. In order to factor a trinomial, always we want to see if we have the common factor. So look at 3, 3, 6. You will see you have factor 3. 6 is 2 times 3, so each of them has 3 as a factor. So we take the 3 out. Each term divided by 3, you will have x squared minus x minus 2. So each term divided by 3. Then after that, in the bracket, you will see you have simple trinomial. So 1x squared, you don't have other choice, is x times x give you 1x squared. Then we want to find two numbers times together is negative 2, add together is negative 1. Then we want to put the two numbers we found in these two boxes. So 2 is a prime number, you don't have other choice, it's 1 times itself, 2. Then the larger number need to be same sign as the sum, so it will be negative 2. Times together negative 2, so one number negative, another number will be positive. Then double check. 1 times negative 2 give you negative 2. 1 plus negative 2 give you negative 1, so it works. Simple trinomial, we can put these two numbers in the bracket. Plus 1 minus 2. Then this is factored. This is equal 0. We are looking for the x value makes this equation equal 0. So we could divide it 3 to both sides, get rid of the 3. So this is 1, this is 0. Two factors times together is 0. Then either of them could be 0. So x plus 1 could be 0, or x minus 2 could be 0. We solve for this one, we move the plus 1 to other side to isolate x. This is a linear equation. Then you will have opposite negative 1. This minus 2 move to other side, its opposite operation is plus 2, so x equals 2. So you have this 2x coordinate, and don't forget, you need to find the y coordinate too. So sub x equals negative 1 back into the equation 1, because it's linear, it's easier to find the y. So sub x equals negative 1 into y equals x minus 2. Then you will have y equals negative 1 minus 2 give you y equals -3. So we have one of the point is -1, -3. And do the same thing, sub x equals 2 into y equals x minus 2. Then you will have y equals 2 minus 2, give you y equals 0. So another point is 2, 0. And these are the two solutions. Therefore, the point of intersections are -1, -3, and 2, 0. So this is a full solutions for this linear and quadratic system. And we are going to do another one. Another one is y is isolated in the equation 2, so we are going to sub equation 2 into equation 1. Then we are able to get rid of the variable y. So sub equation 2 into equation 1. And if none of the variable isolated, we are going to solve it. We use a linear equation to solve for the x or y, or pick which the number at front is 1, then we use that one to isolate the variable. So this one, sub equation 2 into equation 1. You will have 3x plus 2, we replace y with its equivalent. So it's 2x squared minus x minus 3. Then get rid of the bracket to collect the like terms. So 3x plus 4x squared minus 2x minus 6. Then make sure one side is 0. So move the -5 to other side. You do the opposite operation. Then collect the like terms and write it in standard form. Standard form means the degree is decreasing. So 4x squared first, then like terms. 3x minus 2x give you 1x. Minus 6 plus 5 give you -1. Then you could try the factoring. You will find out that you are not able to find two numbers times together is AC, give you -4, and I together is 1. 1, 4, 2, 2, none of them will work for the factors of 4. So we are going to use quadratic formula. So compare it with standard form. A is 1, B is no numbers, multiplication means you have 1 there. C is -1, so A is 4, the number at front of x squared. Then quadratic formula is x equals -b plus minus square root b squared minus 4ac all over 2a. Then we sub in a, b, c. So b is 1 plus minus 1 squared minus 4 times a is 4, c is -1. Then all over 2 times 4. Then continue, simplify it, you will have x equals -1 plus minus square root 1 minus 4 times 4 times -1 is -16. So 1 minus -16 give you 17. Then all over 8. Then get your calculator out to find out the x plus x minus equals what. So x plus, you will take the plus sign. So it's -1 plus square root 17 over 8. And x minus is take the negative sign, -1 minus square root 17 over 8. Then get your calculator out, you will find out x plus approximately equals 0.39 and x minus equals negative 0.64. Then don't forget you are going to take the sub x plus x minus back to find the y value. So equation 2, the y value is isolated. You could sub into the equation 2, or you could sub into the equation 1, then isolate y and solve. But y in the second equation is isolated already, so we sub this x plus to the equation 2. So y equals 2 times x squared is 0.39 squared, then minus 0.39, then minus 3. So just replace all the x values with 0.39. Then use your calculator, you will find out it is equals negative 3.1. Round it to 1 decimal place. The middle steps keep one more decimal place, 2 decimal place. Then y plus 1 minus, this is another, sub in the negative 0.64 to find out another y. So minus negative 0.64, then minus 3. Get your calculator out, you will find out it's approximately negative 1.5. Then write a statement. Therefore, the point of intersections are 0.39, negative 3.1, and negative 0.64, negative 1.5. So this is how you solve a linear quadratic system. So one is a line, another one is a parabola. Then you are looking for the 2 points of intersections. And this, we have both got 2 points of intersections, and the next page we are going to see it's not always you are going to have 2 points of intersections. Sometimes you may have 1, sometimes you may have 0. So let's discuss about the number of zeros or number of solutions. So the zeros of a quadratic function, we could use this quadratic formula or by factoring. So there are 2 ways to solve a quadratic equation. So if factorable, then using the factor method. If not factorable, then just use a quadratic formula. And the number of zeros you will see from quadratic formulas under the square root. If the square root equals 0, then plus minus 0, you will have minus negative b plus 2a only. So x equals negative b over 2a only. Plus minus 0 will be same. If greater than 0, then you will have negative b over 2a plus a number minus a number. You will have 2 different roots. And if under square root you square root a negative number, then it's error, undefined, so no solutions. It corresponding to our linear and quadratic system will be, you have 2 points of intersections with x-axis, that is for the first one. The second one, equal 0 means the vertex is on the x-axis, so you have 1 point of intersection. And the last one, it means your U-shape is below or above the x-axis, and it will never ever intersect with x-axis, so no solutions. And if a quadratic function is given in vertex form, it will be easier for you to see without doing the b squared minus 4ac, the discriminant. Without doing this, you are able to tell it is 2 zeros, 1 0, or 9 0. So if a and k, this q value is negative and open up, you have two equations. This one, a value is positive and q value is positive. You have the two same sign, then it will be no zeros. This one, open down, a value negative and q value negative, you don't have any solutions. So both positive or negative, no solutions. And if the q value is 0, it will be on the x-axis, so you have only 1 zeros or 2 equal zeros. If different, so q value is negative, a value is positive, different, then you will have 2. Or you go another way, so q is positive and a is negative, you will have 2 points of intersections. So this one you could just sketch it. You will be able to see how many zeros. So let's practice to find how many zeros there. So this is a vertex form. So this one, a value is negative, q value is negative. It means you have 2, negative 3 here and open down. So it means there's no zeros or 0 zeros. And the next one, a is positive, q is positive. It means this is a 210 and open up. So this one, no zeros again. So same sign, no zeros. This one, 2, negative 3. So you have 2, negative 3 here and open up. You have different sign, so 2 zeros. So we find the PQ, then this one, a negative, q positive. This one is a positive, q negative. Different sign, you have 2 zeros. So q is 210. And open down, so you have 2 zeros. And the last one, a is negative, q is 0. It means you have the vertex right on the x-axis. So you have 1 or 2 equal zeros. So this is from vertex form. And be careful that this is not vertex form, so it's not APQ here. This is called ABC, okay? So for this one, you couldn't use, okay, A positive, Q negative. This is not Q, so we don't know if it has the 2 zeros, 1 0 or not. So we are going to use b squared minus 4ac if it's in standard form. If this one positive 2 zeros, so 2 squared minus 4 times 1 times negative 3, then you will have 4 minus minus becomes positive. So you have 16. Then it means you will have plus minus square root 16, you will have 2 zeros. This is positive. So this one is factor form. We know the zeros right away. So zeros is 4 and 5. 4 0, negative 5 0. then if you can find the zeros, then you are able to tell you have two zeros. This question didn't ask you where the zeros are, it just asks you number of zeros. So the answer will be 0, 0, 1, 0, or 2 zeros. The next one is standard form ABC, not APQ. So it's b squared minus 4ac, test it to see it is positive or negative. So b is negative 4 bracket squared minus 4 times 2 times 5. Then we have 16 minus 40 give you negative 24. This is a negative. In the quadratic formula, you will have square root. Negative 24 is undefined, so no zeros. And the last one, negative 2x squared plus 4x. A is negative 2, B is 4, and C, no numbers, means plus 0. Then we sub in b squared minus 4ac. You will have 4 squared minus 4 times negative 2 times 0. You will have 16 minus 0 is 16, is positive. So you have 2 zeros. So the answer for number of zeros, you will see you have 2 zeros, 2 zeros, no zeros, 2 zeros. So the answer will be 0, zeros, 1 zero, or 2 zeros. It didn't ask you where the zeros are, okay? Now we are going to see where we are going to use a number of zeros to solve problems. So example 3, it asks you to determine the value of k so that the quadratic function has 2 zeros, only 1 zero, and no zeros. The applications is in example 4. So a line is a tangent if it intersects with a problem only once, only one point of intersection. We call this line is a tangent for this problem. And in order to determine the one point of intersection, so we want to practice how we can find how many zeros there, how many point of intersections there. So determine the value of k. So we have a k value in this quadratic function. This is function notation. F of x is interchangeable with y. Has 2 zeros, only 1 zero, and no zeros. So we want to start with only 1 zero because we know these 2 zeros is corresponding to b squared minus 4ac is greater than 0, and only 1 zero corresponding to b squared minus 4ac equals 0. This is an equation. So we want to start with equation first, then after that do the inequalities. And no zeros means that discriminant is less than 0. So we are going to see, compare it with a, b, c. ax squared plus bx plus c. So a equals 2. And b equals negative k, so you have a perimeter here, and c is positive 8. So we sub in this abc to b squared minus 4ac. We have negative k bracket squared minus 4 times a value times c. Then you will have k squared minus 4 times 2 is 8, 8 times 8 is 64. So for the b, only 1 zeros, we need to have this b squared minus 4ac plus minus square root is 0. Then you will have only negative b over 2a as a zeros. So we'll write k squared minus 64 equals 0 to solve it. You could do the factoring. So it is the difference of squares k plus 8, k minus 8. Or you could do the isolate because you have only k one variable in this equation. You could move the negative 64 to other side. You will have k squared equals positive 64. Then square root both sides. You will have plus minus 8. And here, factoring, you also could have the zeros is minus 8 and k equals positive 8. So the zeros will be opposite with a number inside the bracket, or you could use k plus 8 equals 0, k minus 8 equals 0 solid. So k equals negative 8, k equals positive 8, you will have only one zero. Let's graph it, and so when k equals negative 8, you will have y equals 2x squared minus negative 8x plus 8. That is the red graph. And you will see there is only one point of intersection with x-axis, so you have only one zero or two equal zeros. So this is for k equals negative 8. And if k equals positive 8, you will have 2x squared minus 8x plus 8. That is a blue graph. And you will see now you have one point of intersection with x-axis. And after that, the question asks you how you are going to change this k value. Then you will have more than one. You will have two point of intersections. So this one, no point of intersections if k equals 1. Then you will see if k equals 4, you will have, if k equals 8, you will have 1. If k greater than 8, you will have more than 1. You have 2. So this is what question asks you to find. Then you will see if k value is negative 8, you have 1. If less than negative 8, you will have 2. So we are going to see how we can prove that you are going to have what's a k value will give you 2 zeros. So that is a question A. So 2 zeros means b squared minus 4ac need to be greater than 0 than plus minus a positive number here. It will give you 2 values. Now you have 2 zeros. So it's k squared minus 64 greater than 0. So k squared, move the minus 64 to other side, is greater than 64. Then k value, we know it equals 8 is 64. If k greater than 8, then the squared will give you greater than 64. And if k value is less than negative 8, then you have negative 9, negative 10, it will be greater than 64. So is k greater than 8 or less than negative 8? And the question C, no zeros. It means b squared minus 4ac need to be less than 0. So k squared minus 64 need to be less than 0. So k squared need to be less than 64. So then we know that if k less than 8, 7, it will give you less than 64. And also if k greater than negative 8, negative 7, you will have less than 64. So this is a negative 8 to positive 8 will give you k squared minus 64. And you will learn further how to find these equations. So another way you can find it is k, you have y equals k squared negative 4, 64. Then if we graph this parabola, negative 64 is your vertex. Then you have two zeros, negative 8 and positive 8. If we sketch it, then you will see that if k less than negative 8, it's positive for this b squared minus 4ac. If k is greater than 8, it will be positive. But between negative 8 and positive 8, this k squared minus 64 is negative. It's less than 0. So you also could graph y equals k squared minus 64 to check where you are going to get y value positive, y value negative. So this is for example 3. Now we are going to see how we can use a number of zeros to determine the equation of the line that is a tangent to a parabola. The problem is y of x equals x times 6 minus x. So we are going to see, in order to find the equation of a line, so we could use a y equals mx plus b, but because we have the b squared minus 4ac, we have abc in the quadratic equation, so we want to use not b, we could use maybe the n to represent the y-intercept. So, and m is 2, so we could write it the equation in y equals 2x plus n. And we want to find the equation, we want to find the n value. So another equation, we have two variables. Another equation is a parabola, is f at x. We replace f at x, use a y. So y equals x times 6 minus x. So in xy notation, it's easier for us to solve for the point of intersection. So we have equation 1 is a line, equation 2 is a parabola. In order to find the point of intersection, we are going to get rid of one variable. So sub equation 1, y equals 2x plus n into equation 2. Then we replace the y with the equivalent. It will be 2x plus n equals x times 6 minus x. And in order to solve a quadratic equation, we need to move everything to one side. So we are going to expand the x times 6, 6x. X times negative x is negative x squared. X times negative x give you negative x squared. Then equals 2x plus n. In order to solve a quadratic equation, we want to move everything to one side. We don't want to see negative 1x squared, we want to see positive, so we move the 6x and the negative x squared to other side. Minus x squared to other side becomes opposite, it's positive x plus x squared. Minus positive 6x becomes minus 6x. Minus 6x plus 2x is minus 4x, then plus n. We are looking for the n value, so this is one equation with two variables, and we couldn't solve it, but we could use b squared minus 4ac equals 0 because the n need to be only one, give you only one solutions. So one point of intersection, so b squared minus 4ac need to be 0. So we have another equation, then we are able to solve for this n value. So this one, a equals 1, b equals negative 4, and c equals n. So we sub in this into b squared minus 4ac equals 0. We have negative 4 bracket squared minus 4 times 1, then times n equals 0. Now you will see one equation with only one variable. This is an equation we are able to solve. So 16 minus 4n equals 0. Then we isolate the variable, so we move minus 4n to other side. You have 4n equals 16. Then in order to solve for n, we move the 4 to other side. By doing opposite operation is division, so n equals 4. Now we have the equation of the line is slope is 2, y-intercept is 4. So this equation, we solve this, solve the point of intersection with f at x. You will have one point of intersection because the b squared minus 4ac is 0. So we call this equation is, this line is a tangent. So one point of intersection, so y equals 2x plus 4 is a tangent. Then the question B asks you to graph it. So we are going to graph the line and also f at x on the grid given, okay? So we are going to graph it. So this x-axis and another one. Okay, so we are going to redraw it. This one, x-axis. And for the y-axis, we are going to graph here. So this is x, this is y. And the 2x plus 4, this is a y-intercept. It's on the y-axis. So we could go by 2. The reason how we can graph it is we have the y equals x times 6 minus x. So this is for question B. From here, we are able to see the zeros will be each factor equals 0. So x equals 0, 6 minus x equals 0, give you x equals 6. From these two zeros, we are able to find the vertex. So this is 0, this is 1, 2, 3, 4, 5, 6. And the vertex will be at the middle of these two zeros because it's symmetric on this axis of symmetry. So AOS is axis of symmetry is x equals 3. Then from the p-value is 3, we sub it back. So sub x equals the midpoint, 0 plus 6 divided by 2, average of the two zeros give you 3. Sub this one back into the function, so 3 times 6 minus 3, it gave you 9. So we have the vertex is 0, 9, 3, 9. So then based on this 9 is open down, we are able to label this scale. So 2, 4, 6, 8, 10, 12. So 9 is here. Then we can connect those points. So it will be, this A value is -1. So left one down 1, right one down 1, then down 3. This one, left one down 3. Then connect them. You have this f at x, the problem. So f at x equals x times 6 minus x. Then this is a straight line. we are going to find the y-intercept is 4, then slope is 2 over 1, it means up to rect 1. Then connect these 2 points, you are able to find this line, the tangent. Okay, so we could move it a little bit. Okay, so this is equation, the line y equals 2x plus 4. And you will see you have 1 point of intersection. Okay. Then this is a question B, and question C asks you determine the equation of the line that have a slope of 2 and intersect the f at x twice. So you will see if we are going to be able to move this line. So this is both direction with arrows. Move this line down, you will have 2 points of intersections. If you move this line up, then there's no point of intersections. Move this down means y-intercept is less than 4. So this is from the graph we are able to tell. Twice, then the n value need to be less than 4. So move the whole line down. And never, it means if the y-intercept is greater than 4, then there is no point of intersections. So from this question, you see that by using the b squared minus 4ac equals 0, you are able to find the line of tangent, the tangent line for the problem. And thanks for watching.